It's good to be back. I presented last CHI-NOG. I presented on something very edgy, a little bit maybe too edgy, a little pushing the envelope with blockchain and networking. And this is going to be a little bit more mainstream, hopefully still interesting, and there's a lot going on. So I'm here for a couple of reasons. I have been meeting with service provider customers over the last year talking about SRv6, and there's three common questions that they typically ask. What does SRv6 give me that MPLS doesn't? Does it work interdomain? And how in the heck do I migrate my existing MPLS network to something like SRv6? I mean, many cases they've had MPLS network for a couple decades. They've been sold on going to segment routing, particularly SRv6, now that it's more mature, and they don't know how to go about doing it. And we haven't always had a good answer to that. And maybe we still don't after the end of this presentation, but we're trying. And the reason I submitted a presentation proposal now, and this is the first time, as far as I know, this topic's being presented here and maybe even in ANOG, is that there, within the IETF, there's 7 areas, routing and applications and security. And there's also an operations working group, as many of you know. And there's a fairly new working group called SRv6 Ops, and it's working on operational aspects of deploying and managing SRv6 networks. And it's just a forum for network operators like many of you. And these are the drafts that are relevant to me and to what I will be presenting today, especially that middle one. It contains what I will be presenting today, and we're hoping to get some feedback after the presentation to maybe further enhance this, because for the most part, we're vendors. I've always worked for a vendor, and we need more operational feedback on this. So there you go. This is my only commercial slide. I have these 3 books. I'm not involved in these books. I've worked with many of the authors. I recommend them to you. They're great resources to learn SRv6. The ones on the edge are all about SRv6 and a little bit of deployment. The one in the middle is all about deployment. It's either this or reading a bunch of RFCs. All right, so kind of as I mentioned at the beginning, we are continually developing new protocols. We're evolving new protocols, maybe even more than we should. MPLS has done a fabulous job of providing traffic engineering over non-standard paths, being able to separate that control plane and data plane and using policies and labels, and it's been very successful. But it's also fairly involved. It can be anyway with multiple protocols. It may not scale to some large operators' needs. And so again, they've been moving towards segment routing. And so I'm just going to kind of briefly touch on that first question that they had. My main purpose of this presentation is on the deployment question, but some of you may not be familiar with segment routing, so I'm just going to cover it a little bit and then answer the question about interdomain and then work on deployment. So just really briefly, segment routing is a source-based routing technology. It simplifies traffic engineering by encoding the path directly into the packet header. It can do that either through using labels or an IPv6 address. You have segment IDs. Each segment, well, first of all, path is divided up into segments, and the segment IDs are the unique identifier for a segment. There's 20 or so of these SIDs that have been standardized in the IETF. You don't have to use a standardized one if you don't want, if you want to create your own, if you have one vendor in a very controlled environment, but there's several standardized SIDs, node SIDs, adjacency SIDs, and a variety. And it just does hop-by-hop execution, and each router processes the top SID and then forwards the packet. Again, either using a label or an IPv6 address. On the left there, you can see how it would be using a label. If it's using labels in the data plane, then it's SRv6. If it's encapsulating those SIDs in an IPv6 address, then it's in the data plane, then it's SRv6. And that's what our focus is today. The extension header of an IPv6 packet is really where SRv6 works. There's a routing header, and there's a new segment routing header where you have this list of segments that the path needs to follow, and that's carried in this extension header, and it processes the header if it's active, as SRv6 router does, and then it moves the next segment into the destination address of a IPv6 address. So if you have a network where you have IPv6 but no segment routing, they just are forwarding the IPv6 address. They don't need to look at the actual segment routing header for more processing. So on the bottom left there, you can kind of see an example of a SRv6 SID. You got the locator. You've got the function of what that SRv6 router needs to do with the packet. In this case, it's saying to decapsulate the packet and look at a IPv4 table. It's used in an environment where you're going from SRv6 to IPv4 environment. And then you can have optional arguments to do really whatever you want. So the answer is just really, it provides a lot of flexibility, as SRv6 does. You no longer are using labels, you're just using IPv6, and it's easy to introduce new features, and it's a good foundation for innovations. One slide on interdomain, because that's the second question. SRv6 was designed to work in control environments. It wasn't designed to work across the internet. I think most people would agree with that. It works best in an operator-managed domains, data centers, et cetera. The traffic engineering policies are centrally managed. Networks do need to support IPv6 extension headers. If you're stripping those or not supporting them, then that would not work too well for SRv6. So you need to kind of have an environment where you're cooperatively managing the network. So the answer is yes, SRv6 does work interdomain. There's IETF standards that help make that happen with BGP extensions, et cetera. And vendors have their own solutions, non-standard solutions as well. All right, so progressive versus direct evolution. So now we're going to talk about deployment, and this is going to be kind of on the high level, and then I'm going to talk about several options that are available to you. So let's say you have a conventional MPLS network, and you are convinced that you want to move to segment routing. Well, you can do it one of a couple different ways. You can either migrate to SR MPLS, which is less risky. You're able to just continue to use labels. The hardware would already support labels. It would be relatively easy to just introduce SR MPLS with a software upgrade, and that would be attractive for many people. And then you can later, if you wish, if you then wanted to upgrade your network with IPv6, then you can introduce SRv6 in kind of a progressive evolution way. Or you can just go for it. You can just go direct evolution, and you have your conventional MPLS network, and you said, you know what, SRv6 is mature now. SR MPLS has been around for a long time, much more than SRv6, but SRv6 is ready to go, and all the vendors support it now, and so let's just go to it, just upgrade our network, and make it shine. And so I'm going to share a variety of scenarios how all this will work, and time permitting, I'm going to share some use cases as well from an actual operator. So if you just look at that top rectangle, let's say you have an MPLS network. The presentation after me is going to talk about overlays, so I don't need to get into a whole lot of detail here, but this is one popular way of migrating your network to an SRv6 network. You can leave your MPLS core alone, just have SRv6 configured on the edges, and then just tunnel over your MPLS core. And then eventually you could, if you want, go straight to SRv6. Another way you can do it, and there's three ways I'm going to cover in this presentation: overlay, interworking, and then ships in the night. Interworking is a newer option available that some vendors support that's being worked on in the IETF, and it's not standardized yet. And that is where you're actually using something like a segment routing mapping server to stitch the two different worlds together. They maintain their separation, but you have some routers that are bringing those two worlds together. And I'll share some examples there. Ships in the night is the one that initially came up. When this was brought up in the SRv6 Ops working group, initial reaction was just run ships in the night. That's just kind of the answer to everything, and it makes it easier. It certainly is a good solution. The example that I'll share certainly will agree with that. They coexist. There's no interoperability between them. You have multiple control planes and data planes, and they're doing their own thing. And I'm going to share some examples of doing so. There are some drawbacks because you are maintaining two different systems, and maybe there's hardware that doesn't do too well with that. So I'm going to go from in my opinion, the least popular to the more popular scenarios. So first, interworking. How can we get these two together? And we can do it in kind of a stitching way. So there is a draft. That's the draft that's being worked on in the spring working group that describes this SRv6 to MPLS interworking procedures. There's new SRv6 behaviors. There's new MPLS labels. There's stitching across the different data planes. SRv6 to MPLS and MPLS to SRv6. There's a interworking border node in between that will take an SRv6 SID from a PE or from a route reflector and then forward a label to the MPLS side, and then the same vice versa. This is kind of how the packet flow would work. You've got the gateway in the middle that's doing this interworking function. You've upgraded it, and it supports this feature, and so it's able to allow translation between these two worlds. I think you can maybe think, it may be a stretch, but you can maybe think of it as like a 464 XLAT or NAT64 perhaps, where you're doing translation between the two different worlds. And just like I mentioned on the previous slide, when you receive a packet from the MPLS domain, the PE2 gateway router in the middle is going to pop that label and then search the corresponding VPN instance and then forward that to the SRv6 domain. And same thing the other way. All right, so that's interworking. Let's now talk about ships in the night. And this is, it is popular. It's a popular way to do it. Operators are doing this today, where you're running separate MPLS and SRv6 network. They have the resources to do that, and it's a little bit easier for them in many cases. There are drawbacks. I mean, it can be complex and processing power and all that. But the good thing is that migration can be performed gradually without a flag day. And I'm going to go through a scenario here where you just take your MPLS environment, you configure IPv6, you then configure SRv6, and then if you want, you can disable MPLS and then move from there. So let's quickly go through these scenarios. And so we have this environment, MPLS environment. Today, it's running LDP, probably RSVPT as well. It's running a routing protocol like ISIS, which is a popular routing protocol, by the way, with operators, because when you want to update ISIS with V6 or SRv6 support, it's just an additional new TLV. It's just a software upgrade. It's not a new protocol. And then you've got route reflectors that are forwarding VPN v4 information to keep the PEs from all having to peer with one another. And you've got this green VRF. So I'm certainly simplifying a potentially involved process. Sometimes this takes years, as I'll show in a little bit here. But you configure IP addresses, IPv6 addresses. So now you have dual stack running. You would then configure SRv6 addressing space. You would specify out of your IPv6 address range. This is the ones we're using for SRv6 SIDs. We're going to add a route reflector that supports v6 and that can also distribute the IPv6 and the SRv6 SIDs. And so right now we have ships in the night. They're doing their own thing. The VPN is able to support both, which is one nice thing about BGP and VPN is that they're able to support both MPLS and SRv6, but it's doing so in ships in the night mode unless you use some other mechanisms for some interworking between the two of them. And then you can think about slowly migrating some of your traffic from the MPLS world to the SRv6 world. Some of the services, maybe keep the VPN service on MPLS and then any traffic steering, any kind of service chaining, things like that, you can start moving to SRv6 until you only have SRv6 remaining. and you just are running ISIS, VPN v6. You can remove all the MPLS related configuration, including VPN v4 and the route reflector. You can remove that. And so that's kind of the goal of a lot of the customers, is to do what I just described here. Of course, again, it's pretty involved. This breaks all PowerPoint rules, and I'm not going to go through this list, but this just kind of gives you an idea of what we have in the draft. So this is really kind of the crux of what we want to be able to do in a standards way, because you can go to vendors' websites today and you can kind of see what they suggest. But in environments where you have multiple vendors, and that's what standards bodies, that's their purpose, is to allow this interoperability. We want to be able to have some evolution steps that can just be some basic steps that people can look at to know this is how we need to evolve our network if we've convinced that this is the way we want to go. You're configuring IPv6 addresses, locators, configuring our routing protocol, doing some things with BGP, and then at the end, if we want, delete MPLS and the BGP peer relationships. So this is the crux of what we're working on. And I hope that you guys would be interested enough to look at that draft. If you want to get involved, we welcome it. We need more feedback. If you haven't been involved in the IETF, this may be a good opportunity to do so. How about overlays? Again, I think the next presentation is going to get way into overlays, so I don't need to. And this may be stretching the definition of overlay a little bit, but this is the simplest way. Instead of doing ships in the night, you can use an overlay environment. So let's say you do have IPv6 in your network. You only need to configure the SRv6 PEs with SRv6. The nodes in the middle that are just forwarding packets on the destination address. It's just running native IPv6. It's just IPv6 plus a segment routing header. They're just not looking at the segment routing header, and the SRv6 routers are. I guess it's overlay because the routers in the middle are not looking any further than the destination address. But this is true overlay. So if you have an environment where we just can't upgrade our routers right now to IPv6 in the core, there are mechanisms that you're probably familiar with that can override that. And so there's something like 6PE, 6 Provider Edge, where you're able to encapsulate that data in MPLS. It does introduce a label in the core, but it works quite well. And so there are some mechanisms there. Similarly, with L3 VPN, you can do similar kind of a thing. You can run L3 VPN v6, which supports IPv6 and allows BGP to forward the SRv6 SIDs. You have an additional label. You've got the control plane level in the core, and you've also got the L3 VPN label. But for some people, that may not matter. And so this is another option. If you have like an operator environment where you're trying to transition over a third-party network, this is a pretty good solution. And that's true for L2 VPNs as well. Same kind of thing, but we're using a L2 interconnection and with the ability to forward the SRv6 information from one side to the other, from the PEs to each other. Also introducing an outer label and then an L2 VPN label. And then last slide, as far as this goes, before I get into a use case, is it can get pretty involved, as you can imagine. It's not usually just all clean. And so you may have an environment where some parts of your network just are not going to be able to support for a while anything to do with segment routing. Scenario 2 would be the ideal environment where you have these, the ability to do an SRv6 overlay from end to end, and then maybe run something like 6PE in the core if it doesn't support it. But let's say in scenario 1, and we're going to try to cover these all in the draft, and there may be others. There undoubtedly is other scenarios. But like if the metro doesn't support SRv6, it supports MPLS VPN, then you can stitch that with the SRv6 using option A. Many of you may be familiar with the MPLS L3 VPN option A, which allows for VRF-to-VRF connectivity. And same kind of concept is within SRv6 as well. But if you take scenario 1 and you are able to upgrade the metro to SRv6, you can get to scenario 3 and then extend SRv6 over towards just past the core use option A to connect to the MPLS environment. So there's a lot of permutations to this. And so this is what we're trying to cover. Just know that there are options for you. They're all except for the inner working, this actual translation mechanism, are standards based today, and it's being worked. So this also can show that interdomain works pretty well. All right, case study, and then I'll wrap up. So Turkcell, they recently joined our draft. They're a very large operator in Turkey, which makes sense. They have a pretty complex MPLS environment, and this kind of shows an enterprise circuit, end-to-end full mesh with RSVP-TE. They're running MPLS in the core. They've got LDP running there. And so they have said, they've presented this, and they gave me permission to share their slides, is that it's just really complex. And they know they want to move to segment routing, and it will definitely simplify their environment. And this is how that would go, is they would be able to just use just a couple protocols, BGP and then an IGP that's been updated to support SRv6 SIDs. And this has been their journey, so we can use them as an example. And there's probably many that we could use, but I just happen to know them, and they've been presenting this quite a lot. So they first rolled out SR MPLS, activated it. SRv6 wasn't mature at the time. They were focused on readiness for 5G. And then the pandemic hit, and they put everything on hold. And why would they do that? Well, because they had to just focus on capacity at that point, like a lot of people did. That was their main focus, is increasing capacity. Everybody's working from home and stuff. And then in 2023, they decided that, you know what, we're going to stop SR MPLS. All of our vendors now support SRv6, and so we're going to focus on SRv6. And so last year, they started doing a variety of tests and started readiness. The readiness, if you go to IETF, and even at the most recent forum in France, I think it was, they go into quite a amount of detail on this. But it is important. They saw a lot of compatibility problems, especially with controllers. With SRv6, to establish the policies at the source, you can use a controller from a variety of vendors, or you can use applications or routing protocols to instantiate that policy at the source. But sometimes those controllers don't have all the features for products that are not their own, which is kind of common, and they found that out. And so, they decide maybe that we'll create our own controller. That's a possibility. It's also important to define a roadmap, SRv6 roadmap, to train people. They said that this is one of the most difficult things, was to just get people to be willing, especially the diehard IP MPLS guys, to be willing to do something different than IP MPLS. The more they got to know about it, then the more comfortable you become with it. And then you start procuring software and hardware that does support SRv6. They're ships in the night fans, and so when they rolled out SR MPLS, they rolled it out on their production network. They've since decommissioned that, and their plan is to then, in ships in night, put SRv6 into their network, similar to what I just described. They're also having a pilot network, and they're going to just test everything on that network, first of all, with some friendly customers. They have a lot of vendors, and some of you may as well, and so it's kind of really important to do that. I mean, like I think I mentioned, they have 5 customers. They have 5 vendors, and they've got at least 2 vendors in each of the access, segregation, and core. So it's just a lot of work. So this is their deployment roadmap. This year, they're working on the procurement of the route reflectors. This year, they're going to activate IPv6 on all their network interfaces. And next year, they will update ISIS to be able to support IPv6 and SRv6. And then 2027, get a controller involved and introduce service chaining and TILFA, which is topology independent, loop-free. Thank you. Alternate. So I'm not going to spend, I kind of mentioned addressing a little bit through this. There is a draft in the SRv6 working group, SRv6 Ops Working Group, this would be a good one. It is, I mean, if IP6 has already been deployed and already been planned, then just you don't need to modify that original planning. You just need to select a reserve prefix for SRv6 locators. How am I doing? 2 minutes? Okay. And it's mature. A lot of vendors support it. All the major network providers, chipsets providers support SRv6 today, so you don't have to stress about that, although you may have to upgrade. Your sales guys will love that. And instrument providers also support SRv6. These are the RFCs, so like I said, if you don't want to get a book, then start reading drafts if you're not already familiar with this. So in summary, I've kind of shared a lot, but I hopefully you can just know that there are, if you're interested in updating your network to SRv6 or just segment routing in general, but SRv6 in particular, there are some options to you. Ships on Night is a very valid one. It works well, but there's a variety of overlay options as well. And I hopefully have gone through those clear enough. And interworking is also an option. It's not standards-based yet, but there are some vendor solutions for you. And that's it. That was a lot. But thank you. I don't know if we have a minute or questions, maybe.
I was going to say, I'm really surprised I didn't hear the words MTU throughout that entire
Yeah.
in-cap sandwich. But maybe I'll hear it in the next one. With
hopefully you do. I don't want to deal. I don't want to.
So we run MPLS. I work at Cloudflare. And I was wondering how much is reusable in terms of the SID configs or anything that you already have when you go from that MPLS to SRv6 move, right? Is anything reusable for that migration, or is it all just like a pain in the butt either way?
Yeah, I think it's going to be a pain in the butt because it may be vendor specific. I'm not sure, like configuration wise, if you can just copy. And I don't know how that would work on the vendor side. It's been a long time since I've been on a command, but yeah, I don't have a great answer for you. I think it's going to be a pain, unfortunately.
Hello, Aaron Natach, Akamai. I'm particularly curious about one slide about Turkcell's migration. Mentioned using full SIDs instead of micro SIDs. Could you possibly speak on that a little bit? Yeah, I didn't purposely talk about micro SIDs. So for those who aren't familiar with that term, when you have a segment list, you have all these segments that are full IPv6 addresses. That can get kind of long, and that can take a lot of memory. And so there's ways now that is standard space where you can compress those SIDs and make them much smaller and much more wieldy. I think why I don't know for sure, but I think what I remember them mentioning is that they're more comfortable with using full SIDs and they don't need to worry about any long lists at the beginning. And eventually, and it wouldn't be too difficult to update to be able to go the micro SID route. Great question. Thank you.